Historically, wheel rutting was a significant problem, but is now less prevalent due to improved design and operating techniques. Machines running on saturated soils can cause wheel rutting and can bog. Wheel rutting and bogging results from water accumulating in wheel tracks. There are three ways water can accumulate in wheel tracks. 1. Water directly applied to the wheel track. 2. Runoff into the wheel track. Or 3. Water intercepted by the machine runs into the wheel track. Wheel rutting can occur on all soil types, but is particularly severe on sodic soils.
We find wheel ruts are pretty bad, but I think that's where the education of the grower comes in a bit. I've been to a few systems and the guys have said, I've got really bad wheel rutting on the inner spans. Well, if you've got really bad wheel rutting on the inner spans, this means your pressure's too low, 9 times out of 10. Because what's happening is you're getting more water on your inner circle and you're starving the machine out at the end of the machine. So if you're getting deep wheel rutting on the inner spans, you've really got to do something about it, because obviously your connection pressure is not high enough. So I think there should be like a little tick box. You know, the grower should go back and have a look at the sprinkler system and go, okay, they designed this system for 36 psi, I'm now running at 25, but I'm still getting a product yield out of this. But something's going wrong. I'm missing 10 litres a second, but I'm getting heavy wheel rutting on the inner part of my machine. So maybe something hasn't been set up properly, or maybe there's some blockage in the pipe, or they should be looking at other things, not only just the wheel rutting side of it, because I think a lot of growers get in that focus that, hang on, it must be the water I'm putting on, or the amount of water I'm putting on, or something like that. But yes, wheel rutting is probably one of the biggest problems. I've seen some really deep wheel rutting that, you know, and it costs. Growers don't look at the electrical cost, because when you're running through the deeper wheel ruts, you're actually chewing power as well. But you won't notice it because the demand on the machine might only be 3 or 4 kilowatts. But you know, they could be back at 2.5 kilowatts, which would save them an extra 38 cents an hour. It doesn't seem like a lot of money, but you know, it all adds up. So yeah, management of wheel ruts is a big thing with the machines, and if you can get it on it early, then you're going to solve some problems and heartache for you down the track.
You need to keep that wheel area dry, because and I think in any type of soil, without that wheel being dry, it will, over time, it will just slowly work its way deeper and deeper, and all you have is a rut in the field, and you're trying to get pickers and harvesters, and you just, for the cost of the boom back, you'll save that on your machinery that's working that country. It may not be your machine, but it might be a contractor's, but you still save somebody some money.
Wheel rutting can be minimised by increasing tyre sizes and maintaining tyres at the minimum recommended pressure. This lighter footprint can reduce the incidence of wheel rutting. Other strategies include using a dry run or a light initial irrigation to firm up tracks at the start of the season. Some irrigators use specifically designed equipment to prepare or repair wheel tracks. For example, the track closer is a commercially available implement that can be used to close wheel ruts at the end of season.
On the black soil we use a very simple system, an old sundercut, and we go opposite ways and we just heap it up on top of where the wheel track is. A simple, after each crop, just run around with the sundercut, and you'll find that you've created a drain away from your wheel track as well, and wheel rutting is not a major problem for us. It doesn't to say that you don't get some in very wet weather. The other thing that we have on every pivot has a rain gauge, and as soon as it gets to a certain amount of moisture, you know, and you can 40 points or whatever it is, just turn them off. And try and not water when there's a lot of wind. If there's too much wind, stay away from it, you know, and otherwise your wheel tracks will get water on the last wheel.
There are several possible ways to minimise water accumulating around wheel tracks. These include boom backs, offset booms, directional emitters, and the use of remote drains to deliver drainage water away from the towers at shutdown.
Initially, we'd looked at the broke up the road that had huge wheel ruts when he was one of the first ones. And I said, well, we've got to do something about that. And the company had boom backs, but they were very expensive and they didn't look all that brilliant. So we set to and built our own, and we had them right on from the first year. And we actually run the tyres with about 180 litres of water in each tyre on each tower. That's mainly to try and hold it on the ground in case of a windstorm. So we've added extra weight to it, and we could irrigate 7 or 8 times, and the rut won't be any deeper than maybe 50 mil or something like that, with the boom backs that we've got on.
We put boom backs on our standard machine, and basically growers might ask us to take them off or not to put them on. And a lot of those are the guys who are really buying on a particular price. Most of our clients who've used machines and want to buy another machine just say, no, look, I want them on. It should be a standard item in my opinion. Yeah, wheel ruts is the big problem. It's the problem everyone's heard about from years ago. But there's 2 reasons. It's normally got something to do with your sprinkler package, or you've got some management issues. You've had a storm and you've had wheel tracks there, and you've gone and watered too early. You've been running water. You've got slope in your paddock and it's not contoured, or it wasn't level, or there's normally a reason. Yeah, but wheel tracks are certainly a significant issue.
Best crop performance requires an even application of water or distribution uniformity. Flow meters, pressure gauges, pressure regulators and emitters all play a part in determining distribution uniformity. Flow rate can be measured using an accurate flow meter. Alternatively, it can be estimated by direct measurement of the flow from emitters. This can be done by placing a large container of known volume under one emitter and timing how long it takes to fill. Record measurements from at least one emitter per span and note the span and emitter position numbers. Check these flows against the emitter specification chart. Distribution uniformity requires correct operating pressure across the machine. Insufficient pressure reduces distribution uniformity, whereas excessive pressure increases energy use. Checking pressure gauges provides an indication of system performance. A pressure gauge is usually installed on the centre tower of pivots and on the lateral move cart. Additional pressure gauges fitted before the first emitter and ideally towards the outer end of the machine enable quick verification that the machine is achieving designed operating pressure. Observed changes in pressure can prompt remedial actions. For example, a reduction in pressure may be associated with problems at the pump, its intake or blockages along the span. The accuracy of pressure gauges deteriorates over time. This results in inaccurate and misleading readings. As they are relatively inexpensive, their replacement on a regular basis is recommended, as they so readily enable swift troubleshooting. Pressure regulators fitted above each emitter ensure that water is supplied to emitters at their designed operating pressure. If the system is not operating at correct pressure, emitter performance is degraded. Not all installations require regulators fitted. Regulators are required on undulating country as changes in elevation along the spans influences pressure at individual emitter locations. As a general rule, the pressure above the regulator should be 5 psi above the regulator rating. Accumulated debris will reduce the performance of pressure regulators. Regulator performance deteriorates with age and will be an issue on older machines. The sprinkler package should be designed to achieve high distribution uniformity. Changes to the original sprinkler installation could affect system performance. These changes must be considered on a whole system basis. Each emitter belongs at its specific location as the individual output is matched to ground speed and area covered. This is particularly true of centre pivots, as their required output increases with distance from the pivot point. Correct location of emitters can be checked by reference to the sprinkler pack supplied with the machine. Careful observation of the sprinkler pattern of individual emitters along the length of a machine will identify full or partial blockages that affect application rates and distribution uniformity, impacting crop development and yield. Debris tends to accumulate towards the end of machines, and the outer emitters are particularly susceptible to blockages. With centre pivots, these emitters cover the largest area of cropping, resulting in the greatest negative impact on potential yield. The incidence of blockages increases with irregular flushing and poor maintenance of filters and sediment traps. There are 3 movement and alignment systems available for centre pivots and lateral moves. These are stop-start electric, continuous move electric, continuous move hydraulic. With the stop-start electric system, each tower performs a continuous stop-start movement to move the whole machine up the field. The speed is set by the outermost tower, which is sometimes referred to as the boss tower. Lateral moves usually have 2 boss towers, one at each end. Centre pivots only have 1 boss tower. There is an alignment sensor on each tower. When the alignment sensor indicates that a tower is behind the adjacent tower, the drive motor is started. When the alignment sensor indicates that a tower has moved in front of the adjacent tower, the motor is stopped. As the tower moves, the next tower will sense that it is behind and start to move to keep up. A continuous move system senses misalignment and adjusts the flow of hydraulic oil or electric power accordingly. When a tower is in front, the hydraulic oil or electricity to that tower drive system is adjusted via alignment valves or sensors to slow it a little. The opposite applies when a tower is behind. In this control system, the towers never completely stop. Poor alignment can result in automatic shutdown. This interrupts the irrigation cycle for the crop and can lead to system drainage and subsequent bogging issues. Poor alignment may be due to problems in the guidance system or the propulsion system. As lateral moves are not anchored at a pivot point, they have a more complex guidance system. Irrigators need to have a rigorous maintenance program for their guidance system. Barrier stops are recommended. Consult your supplier to address alignment issues due to some of the complexities involved.
Well, we've got above ground, and at that stage when we put those machines in, the below ground technology probably wasn't up to scratch, and we're worried about the cable breaking in our cracking clays. But I think the manufacturers or suppliers have sorted the problems out there, and by using sand and conduit and all those kind of things, I think they'd have that worked out, and we're probably going to investigate changing the machines over to that because we have had a few management issues with the above ground one. We've got feral animals running into it, but probably the biggest thing is being next to your channel. You can't maintain your cart track or your channel as easy. Desilting and grading the cart track can become quite difficult. So we're considering changing. So I think most people should look to see if those underground ones, and also they've got a new GPS one out, but I personally wouldn't be confident of that because it doesn't always work in the tractors. So, so that's one of the things. But yeah, I don't know. I think probably leave it up to the purchaser to contemplate that, and just remember that the above ground cable can cause a few headaches.
Strong winds can damage overhead machines. Wind across span pipes produces a vortex, forcing the span to move up and down. This bouncing action can increase to the point that the machine topples over. Various strategies have been used to reduce this risk. Where practical, park machines parallel to the direction of severe winds. Installation of check valves to always retain water in spans. This adds weight to the machine. Filling tyres with water. The selection of low-profile towers in areas prone to high winds to decrease span exposure to higher wind velocities. The installation and use of tower tie-down points, for example, along an access road or at the end of the field. It is not always practical to implement some of these strategies. It is important to adequately insure machines against this form of damage.
In terms of insurance, You would insure it like any piece of equipment that's going to be left out in the paddock and is critical to your farm operation because you're irrigating a very large crop underneath. You would insure it the same way. We get asked often about, you know, what do I do if the wind comes? Well, what would you do with your shed if the wind comes? There's very little you can do, you know. And if the wind is that strong that it's going to knock down a shed, you're likely to knock down a pivot. There's, you know, the only things we have seen that have worked is if it's been in the direction of the wind, then as opposed to be perpendicular to the wind, we've seen them, but the machines don't gallop around and the wind moves a lot quicker. Actually switching the machine on, so there's water in the machine. I've seen them anchor the overhang down. Actually, when they have a road that they park it on, they park it. Generally speaking, most farmers know where their prevailing winds and their storms come from, so they have them facing in and then have anchor points down to fix them down. All those things can help. Yeah, I've seen situations where two pivots side by side, one was facing in the wind, one was facing perpendicular, the one was facing in was fine, the one was perpendicular was knocked over. So, yeah.
Burrs can damage wiring, droppers and emitters. Wiring should be placed below the span pipes and protected using conduit. Long weights can be replaced by donut weights to discourage parrots attacking emitters. Control boxes should be sealed to prevent insects, frogs and rodents causing electrical short circuits. Spider webs can reduce emitter function, resulting in poor distribution uniformity.
Because we've got a major bird problem here with cockatoos, the donut ones you virtually have no droppers ever eaten by the birds, whereas the pipe ones can vary from 10 to 50 a year where you'll have to replace them depending on the birds. So on that point, we always hang all of our wires for the pivots under the bottom of the truss and under the water pipe, and that's just cut out any of the bird problems.